and sort of cameras on the head is moving in the way that the robot would move to, say, pick up an object or open a door, or the basic tasks, throw a ball, dance, and we need to I think that's needed to sort of bootstrap the intelligence so you can have the basic functions. Then where I think it gets very interesting, and very much like humans, is that you want the robot to self-play. So you say, how does a child learn? Well, a child has toys, and a child plays with the toys, plays with the blocks, at some point figures out how to put the triangle in the triangle hole and the circle in the circle hole by doing it over and over again. And this self-play, once you have a lot of robots, you can do this self-play, which is that you just put the robot in a room with toys and have the robot literally have the robot play with toys.
And it will learn.
Yeah, and you have to have a reward function. Say like, okay, the goal of the robot is to put, that classic child's toy. You put the circle in the circle hole, the square in the square hole, triangle in the triangle hole, and keep doing it until it works. And the reward function is succeeding. And
there are no advances needed to accomplish that now? I mean, no advances in AI or just compute and things of that nature that can happen?
There are some advances needed, but I don't think these are insurmountable. I think we can solve these things in the next few years.
All right, so that wraps that up. One thing that wasn't really mentioned there, but it was the data side of things. Between like Tesla and XAI, the data centers and stuff that they're building out for like neural net and AI like learning and training and stuff like that is some of the top in the world, like literally the top 5 in the entire world for building out data centers. And not only that, but I think it was XAI just added a bunch of their Megapacks, which is basically battery backups, to be able to have enough power at their facility in order to run the AI models. And also too, if ever there's any outages of powers and stuff like that, they can keep training while other people's are not able to train, and computers shut down and maybe they take a whole day to ramp back up again. Just having that data security there, or that power security, and be able to keep staying up and running is it's just completely different than what you're seeing on the market. Now again, that business is performing really well for Tesla, so Tesla has a battery storage business, if you didn't know that. So that business is performing really well, and a lot of companies are, instead of doing generators, they're doing this battery backup system because it can kick on instantaneously, and you can have no power outages. And if you have no power outages, if you're in manufacturing settings or anything that's a sensitive operation, you can't have power lost to your equipment and then power come back on, because a lot of times that can cause hours of downtime. Just as one little simple power on, like a brownout is what you would call that. That can cause hours and hours and hours of downtime to equipment and manufacturing facilities or offices. And so something like this, just one outage of, let's say 50,000 employees at an office or something like that, one outage, and you not actually lose power and everybody's computers shut off and they have to all boot back up. I mean, what's 1 hour of people booting their computer back up for 50,000 employees? You know what I mean? You get to millions of dollars very, very quickly just on one incident. And that's not even including if there's any multi-hour outages or anything like that. So generators can solve a lot of those problems anyway, but if you have the battery backups, at least as a buffer to get you through a 30-minute brownout while you have your outside generators kick on, it's just a solution for that.